In this lecture, I'm going to go over trigonometry and the derivative of trigonometric functions. So, since we are talking about functions where the domain and range are real numbers, we need to use all the angles in, well, real numbers, which are radian measure. Okay, so although I understand everybody is comfortable with degree measures, but we need to use radian measure because degree measure, when you have degrees, they are not really real number. But when you are using radian measure, that is really real number. Okay, so the conversion is, of course, 180 degree is pi. Then the standard position of an angle is where you put the initial side on the positive side of x-axis and then you rotate. Okay, that is the standard position. Remember, angles are rotations. So you put the initial side on the positive side of x-axis, vertex at the origin, and then how much you rotate the terminal side give you the standard position. And when you rotate counterclockwise, this is positive. Wow, it's a positive angle. Positive direction. And if you go this way, to start here, right? And then if you go this way, this will be negative angle. So counterclockwise, positive rotation. That's positive direction. That's always the positive direction because when we are counting quadrants, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so counterclockwise essentially is like the positive direction of rotation in math. And we have these 6 trig functions. When you are using a triangle, here you have the right green triangle, right? Green right triangle. So here you have all these trig functions of an angle, not of a triangle. Okay, a triangle does not have sine or cosine. An angle, an acute angle in the right triangle has sine, cosine, tangent, cotangent, secant, cosecant. So this is a very bad habit when you say sine equals 1/2. This is wrong. Okay, you need to say the angle. All trig functions are of an angle. And here, theta is here. Then we define the 6 trig ratios, this way. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then we have the reciprocals, cosecant, secant, and cotangent. You just flip them. And when you put an angle in a standard position and you pick any point on the terminal side, if you go toward your x-axis, by the way, you always go toward your x-axis from the terminal side. Okay, this is a right triangle. This is, well, the theta is already indicated in the graph, and here we call it theta bar. That is the reference angle. Well, if you look at this triangle, the red triangle, you have the opposite side, which is y, and x, and r. Okay, so we define the 6 trig ratios by extending what's happening in quadrant 1, where everything's positive, into quadrant 2, quadrant 3, and quadrant 4 with x, y, r instead of opposite, adjacent, hypotenuse. Notice x and y could be negative, but r is always positive. Then we can define trig ratios of any angle, not just an acute angle. And of course, when you are having negative x or negative y, you would have negative sine, cosine, tangent, cotangent, secant, cosecant. So when you are in quadrant 1, x is positive, y is positive, and r is always positive, okay? So in here, sine, which is y over r, cosine theta is x over r, and tangent theta is y over x. These are the three major trig ratios and trig functions, and the reciprocal are honestly not as significant as them, so we will focus on sine, cosine, tangent. In quadrant 1, everything's positive. That's why all ratios are positive. Now, when you're quadrant 2, x will be negative. Well, let me put it in my triangle. X is negative, y is positive, and again, r is positive. So in quadrant 2, the three x, y, r, only y and r have the same sign. So y and r makes sign. That's positive. X and r, x and y are different signs. So cosine and tangent are negative. That's how we know. Let me just write all positive, only sine positive. Now when you are in quadrant 3, where x is still negative, y is also negative, r is positive. Now what has the same sign? X and y. So tan here is positive. And the ratios that I'm not saying are negative. And finally in quadrant 4, we still have the positive x but negative y. And of course r is positive. In this triangle, actually x and r have the same sign, so cosine theta is positive. And that's how we get these four ratios. And then we have everything positive in quadrant 1, sine positive in quadrant 2, tan positive in quadrant 3, and cosine positive in quadrant 4. Well, I think all the textbook make funny phrases to help you remember it. All students take calculus or a smart trig class, whatever, but remember them. And whenever you don't remember them, just go back, do this. You figure out what x and the sign of x and y are, you will get the sign of trig ratios. Okay. These are two very special triangles that will give you all the special trig ratio of special angles, so you need to remember them. Well, first of all, pi over 4 is 45 degrees, okay? And this is 30 degree and this is 60 degree. So you have 45 degree, 45, 45, 45, 90 degree triangle, and you have 30, 60, 90 degree triangle. For the 45 degree, actually I don't like the 1, 1, radical 2 that much. I like the radical 2, and 2 better, because most of the cases you'll see your trig ratios with rad 2, and 2. Okay, because rationalizing denominator. Now the 30, 60, 90 degree triangle. This is how you remember it. The smaller the angle is, the shorter the opposite side is. So 30 is opposite to the smallest angle, which is, 30 degrees opposite to the shortest side, which is 1. And 90 degrees is opposite to the longest side, which is 2. And then 60 degrees in the middle, which is opposite to square root of 3, 1.732, right? Between 1 and 2. That's how you remember these two triangles. And remembering these two triangles, you will be able to tell all the trig ratios of 30 degree, 45 degree, and 60 degree. And also, whenever the reference angle are 30, 45, or 60 degree, you can figure out their ratios. Now, when the terminal side sits on x or y axis, what you do, say I'm here, you just pick any point on the terminal side, and normally I pick the one, I pick one of these four, 1, 0, 0, 1, negative 1, 0, and 0, negative 1, where they have x and y, x and y, x and y, where r is 1 everywhere. Then you can use XYR definition to get whichever trig function you are looking for. Now let's see some examples. Well, we are evaluating these trig ratios. First, I'll convert the angle into degree measure, so I'm more comfortable with it. Pi is 180 degree. So divided by 3, I'm having 60 degree. And I'm having 60 degree. I don't really have to do the coordinate plane, but I want to be consistent. I'll do it anyway. So I rotate 60 degree. I get here, which means I'm having a 30, 60, 90 degree triangle. This is 1, this is 2, this is radical 3. 30 is opposite to 1. And my theta is here. The angle should always be at the origin. The vertex is always at the origin, okay? And your triangle should always share a side on the x-axis, and it never is on y-axis. So if you draw something like this, you see here, it's on y, that's wrong. You always go toward x-axis. Anyway, going back to my question, I'm having sine, which is opposite over hypotenuse, or y over r. So sine pi over 3 is, let me use y over r. This is y, this is r. So radical 3 over 2. The second example, 5 pi over 4 will be 5 times 180 degree over 4, and that's 900 degree over 4, which is 225 degrees. Now I rotate. When you rotate, you count by 90 degree. A 90, 180, I go a little bit more. If I go all the way here, it will be 270, not that much. But if I'm here, that's 180, too little. So I'm somewhere in the third quadrant. Then I draw a line toward my x-axis. And I need to look at my triangle here. This angle in quadrant 3 is 225 degree minus 180 degree, which is 45 degree. So I'm having 45, 45, 90 degree triangle. Radical 2, and 2. I'm in quadrant 3. This is negative, this is negative. Now cosine. 5 pi over 4 will be x over r, which is negative radical 2 over 2. Last, negative pi over 2, taking tangent. Negative pi over 2 is negative 180 degree over 2, which is negative 90 degree. It's a negative angle, so I start rotating this way for 90 degree. And this is the angle I'm having, okay? I pick the point on my terminal side, and that would be 0, negative 1. So my x is 0, my y is negative 1. Tangent is y over x. which is negative 1 over 0. 0 cannot be denominator, and when you have a 0 denominator, which will happen sometimes on tangent or cotangent or secant or cosecant, you just say this is undefined because it is undefined, which means tangent of negative pi over 2 does not exist. Sine and cosine you will not have undefined because they have r as denominator. R will never be 0. Now you can try practice number 1 through number 4. Example 2 is backward. I tell you that cosine theta is negative radical 2 over 2, and I want to recover the angle. Well, remember you are in the quadrant, so you might have, say, pi over 3. You might have 2 pi, then pi over 3. You might have 1, 2, 3, 4, 5 rotations, then pi over 3. We can't. So there are so many answers, right? So I want to focus on just where the terminal side is. So I'm going to pick my solution theta only between 0 and 2 pi. And yeah, I can keep adding rotations or subtracting rotations on them. That doesn't matter that much. Okay, let me take this away. How do you solve it? Two things, okay? When in general, when a trig ratio is given, you figure out the sign of the trig ratio tells you which quadrant. And the value part, the absolute value part, tells you the reference angle. So you look at cosine. Everything's positive in quadrant 1. Cosine is positive in quadrant 4. This is sine's quadrant. This is tangent's quadrant. We are having a negative cosine, so we are in quadrant 2 or quadrant 3. Now ignore that negative sign, okay? You look at the reference angle. You know that cosine theta bar equals square root of 2 over 2. That means radical 2 is here, 2 is here. Adjacent over hypotenuse, right? So what angle is this? 45 degree, because we are having radical 2, 2 triangle. And that means my theta bar equals 45 degree, that is pi over 4. If you don't know how to convert, this is how you convert. 45 degree divided by 180 degree times pi. And then you cancel them. It will be 1 over 4. But I do hope you can remember that 30 degree is, let me put it here, 30 degree is pi over 6, 45 degree is pi over 4, and 60 degree is pi over 3. So you don't need to do divided by 180 degree and times pi every time when you convert a degree measure into a radian measure. I have my quadrant 2 and 3, and I have my reference angle pi over 4. Now I just combine them together. In quadrant 2, I'm here, and this is pi over 4. So theta will be pi minus pi over 4. This is 3 pi over 4. Now quadrant 3, I'm having here pi over 4. And the theta will be, I go pi, then I go a little bit more. Pi plus pi over 4, and this is 5 pi over 4. So these are the two solutions for the equation cosine theta equals negative radical 2 over 2, where my theta has to sit between 0 and 2 pi. Again, the sign of the trig ratio, the trig value, gives you which two quadrants most of the case. If you don't have coterminal, it will be 2 quadrants out of 4. Which 2 quadrants you are in, and then the absolute value part of the trig ratio will let you recover the right triangle. Then you combine them. Of course, sometimes you might get a coterminal angle, which is, sorry, I don't mean coterminal, I mean you will get an angle where the terminal side is on x or y axis. Okay, in that case, you will need to draw the graph, x, y, and r. Anyway, try practice number 5. Next, let's look at the derivatives of trig functions. The derivative of sine is cosine. The derivative of cosine is negative sine. Okay, derivative of tangent is secant squared. Derivative of cotangent is negative secant squared, cosecant squared. And the secant has derivative secant tan, and cosecant has derivative negative cosecant and cotan. So I guess what I want you to observe is, if the trig function that you have does not start with co, you end up with a positive derivative. If the function starts with cosine, cotangent, cosecant, the derivative has a negative sign. Now, knowing these 6 trig functions, we have more sort of base functions. We only had power rule, right? We only have x to the n. Now we have so many other functions, and with, again, addition, subtraction, multiplication by number, multiplication between 2 functions, and division and the power, we can make a lot of combinations, and all of them could be differentiated. So first example, y equals x cosine x. Again, the thing is, you observe what is the last operation, or at the end, what y or f of x is. Is it a power? Is it a sign? Is it a sum? Is it a difference? Is it a product? Is it a quotient? So here is x times cosine x. Imagine you plug in a number. What will happen? You'll find x, you'll find cosine x, and then you are going to multiply them. That is the last step. So for this function, it is actually a multiplication at the end, which means you are dealing with product. And when you deal with product, use product rule. dy dx will be first factor times the derivative of second factor plus the second factor times derivative of first factor. Then cosine x gives me negative sine x when taking derivative, and x derivative is 1. So I'm having negative x sine x plus cosine x. Next, 2x over 1 minus 3 tan x. This is obviously a quotient. That means we are going to use quotient rule. F prime x equals, remember, you square the bottom, then you copy the bottom times top derivative minus what you just differentiated times 1 minus 3 tan x bottom derivative. Okay. Then we need to find those 2 derivatives. The derivative of 2x, of course, is 2. That's easy, right? So this part is easy, and this part will be 0 minus the derivative of 3 tan. That's also not too bad. So let's see. I copy my denominator the same way. I copy this. Now the derivative of 2x will be 2 times derivative of x, which is 1. So 2x, you just get rid of x. Minus 2x times derivative of 1 is 0. Sooner or later I will stop writing the zeros from the constants, but maybe not now. minus 3 is the coefficient. I pull it out. Now the derivative of 10x. First of all, it's positive because it's 10, not co-10. And you might need to look it up at this moment, but you need to remember it. You need to remember all the formulas. So this gives me 1 minus 3, 10x squared. And let me do it next time. Minus 2x. So here 0 is gone. I'm having negative 3 secant squared x. Then this is 2 times 6, 10x. Negative times negative gives you positive. Plus 6x secant x squared. Secant squared means secant x squared. Then the whole thing over the denominator squared. Well, this is kind of huge expression, but as you should know by now, when you start with a little bit complicated expression, things get worse quite fast. Next, cosine x squared. So this at the end is cosine. By the way, I should have said this. Cosine x squared means cosine of x squared. And we don't really write this. We write it this way, cosine squared x. This means cosine x, then we raise it to the second power. Okay, so cosine x squared is, at the end, cosine, a cosine. So we are going to use chain rule. The last operation is taking cosine. Everything before that is u. So we are going to say y equals last operation taking cosine. We leave it. Then everything else, which is pretty much the input of cosine, will be u. So your u actually is x squared if you compare. And dy du is cosine. Taking derivative, negative sign u. And du dx would be 2x. So dy dx is negative sign u times 2x, where, remember, you can't have u in your final answer. You need to tell people what your u really is. Mine is x squared times 2x. So this is negative 2x sine x squared. Last question, f of x equals sine 3x over x squared. This is again, the bar at the end is a quotient. You are going to use quotient rule. F prime x. For quotient rule, I honestly don't think there's much to think. Just go ahead. Quotient rule. So denominator squared, denominator times numerator, derivative minus what you just differentiated times denominator derivative. So what is the derivative of sine 3x? Let me do it sideways. Sine 3x is a sine. When you differentiate it, you will have sine give you cosine. So cosine 3x times the derivative of 3x. So pretty much this is your u. Sine u become cosine u. Where u is the 3x, then you differentiate where u sits. This is cosine 3x times 3. So 3 cosine 3x. I'll bring it in. This is x squared times 3 cosine 3x minus sine 3x times x squared. Taking derivative, bring the exponent to front, lower it by 1. Then x to the fourth power. 3x squared cosine 3x minus 2x sine 3x over x to the fourth power. Obviously, you have an x in the numerator and the denominator as a factor. So I actually, when I observe it, this is what I do. I divide it by x from the numerator and the denominator, which means I divide x into every term. So it will be 3x. I lost the square. I lost the x. And I lose an x on the bottom. Cosine 3x minus 2 sine 3x over x to the third power. And that is the answer. And you can do question practice number 6 and 7.